Hello students. Next we will be dealing about contact forces. Those forces in contact with each other. So what are contact forces? Those forces which are produced by atomic and molecular interactions at short distances. Such forces are called contact forces. Examples are static friction, sliding friction, tension or the force on a string, force of viscosity, etc. are examples of contact forces. So first we take up tension. It is the force of a string. Consider a string. This is the string. We can think of a string as composed of short sections like AB interacting by contact forces. So we assume a string to be composed of small sections which are interacting each other through contact forces. So each section pulls the section to either sides of it, and by Newton's third law it is pulled by the adjacent sections. Okay. The magnitude of the force acting between adjacent sections is called tension. So you can see this piece, this section AB. Here you can see the contact force or the tension is acting at the point A is F, and at the point B it is F dash. There will be an F in the neighboring section or the adjacent section which is equal and opposite to F. Here you can see here this F will be towards the opposite to this F. Okay, similarly there will be an F dash opposite to this F dash nearby or in the adjacent section of B. So in the sketch the tension at A is F and the tension at B is F dash. Although a string may be under considerable tension, for example a string on a guitar, the net string force on each small section is 0. If the tension is uniform, the sections remain at rest unless external force act on it. Unless an external force act on it, the sections remains at rest. Okay. If there are external forces on the section or if the string is accelerating, the tension varies along the string. So, tension is varying along the string when there is an external force on the section or if the string is accelerating. Our next example is a dangling rope. Okay, this is a rope tied at the limb of a tree. A uniform rope of mass m, the total mass of the rope is m, and length L hangs from the limb of a tree. You have to find out the tension in the rope at distance x from the bottom. So, from the bottom at a distance x, what is the tension at this point? So, you can see this diagram. Here W is the weight of the rope and this x length. Here you can see the tension at the point x. You have to find out the tension Tx, T of x. Now you can see, analyze this force diagram again. The section is pulled up by a force Tx, where Tx is the tension at x. The downward force on the section is its weight. You have to calculate W. For that, let us assume the mass per unit length of the rope is m by L. Okay, let m by L is the mass per unit length. Therefore, the mass of the length x is equal to mx by L. This is the mass of this small section x. Okay, so what will be the weight? Weight is equal to mass times g. So mass is mx by L into g. So it is mg x by L is the downward force on the section or the weight of the rope. Okay, for this section. The total force on the section is 0 since it is at rest. So we know that rope is at rest, then the total force on the section will be 0. That means T of x will be equal and opposite to W. They will be equal. Therefore, what will be T of x? That is equal to W. That is equal to mgx by L. So this is the tension acting at the point x in the upward direction on the rope.